We can begin.
Okay. This is
Recording in progress.
all right. Good morning, learners. I want to welcome you to our lesson for today. And I hope as we keep on progressing, other people will join. Okay, so I want to thank you for being part of the program still, every time being available. And I know God has kept you well and you're still alive. And we thank God for the protection and everything that He has given to us. So before we get started, as our usual norm, it is we begin with a word of prayer to thank God for the life and also to ask for God's protection and guidance as we start our lesson and so that God helps us to understand all that we are going to study. Okay, may I request a volunteer to give us a word of prayer before we get started? Daphne?
Yes, sir. Good morning, sir.
Good morning.
Okay, Master. Let me at least start with the word of prayer. Let me take that blessing.
Okay.
Okay, let's humble ourselves for the word of God. Dear loving Father, we thank you for this day. We thank you for the gift of our teachers you always give to us. Father, we thank you for the guidance and also the provision you give to us as we are going to study. Come and be in the midst of us. Let your precious blood come and cover us. In Jesus' name we prayed. Amen.
Amen. Okay, so thank you so much, Daphne, for the prayer. And this is Senior 3 mathematics class. This is where we are. Those of you who are asking which class this one is. Okay, now we did an exam last week, and I want to share a few things with you about what we did. And one, some of us received the work, others, I think I have about 7 people. I think about 7 people out of 57. Okay, out of 57 that have not yet received the work. I think about 7 people. Okay, only 7 people have not received the work yet. So be sure you still receive your work on what you have done. But in total, I had, I think, about 59, 57 learners who handed in their work. I don't know about others. Right now, I have 59 people in the class. I hope you are the ones who have handed in your work. But otherwise, I want to thank you, all those people who finished the work and handed in. Okay, thank you so much. And I believe that we shall progress on rightly and in a right way. Now, those of us who are joining us for the very first time, we've been looking at probability. Okay, that is what we've been looking at, and we looked at several things as far as the probability is concerned. We looked at several things as far as probability is concerned. And one of the things that we looked at there were issues to do with the die and then the coins. Okay, the die and then the coins. We saw how we can try to work out them as far as probability is concerned. So, and our exam was all about this. I think we also did some part of course, the introduction. In the introduction, we say that when we are finding a probability of an event, we say it is literally the number of the events out of the number of the sample space. That was our introductory part of it. And this is the key part as far as our probability work is concerned. So this is the bottom line that we need to have. But when we look at the dice and then the coins, it is something that I really want us to pay attention to. And I'm going to do a lot of emphasis as far as this is concerned, the dice and then the coins. We see how we can work it out. So in my revision, in the revision that we are going to do for the previous paper that we did, I'm going to basically emphasize the part of the die and then the coins, how we can toss and then roll the die so that we can be able to come up with the probabilities that we need. So that is what I'm going to emphasize mostly about, especially for those who just joined. Especially those who just joined, please pay attention as far as this is concerned. So in my lesson, I'm going to emphasize these questions here because some of you were messing them up at some point, while others were doing so well. I'm so happy about that. While other people, they need to try to revise more and practice more so that you can be able to carry on. I think the highest mark was about 95. There's someone who got 95. Yeah, the lowest. Some of you didn't hand in the work. I didn't check it. When I checked through the work, I didn't see it. So I don't know why. But you handed in empty work. So I think you checked through. But most of you, I'm sure about 53 learners have received their work out of the 59, those who handed in. Okay, so we are proceeding with our revision and maybe let's share this. Unless someone has an issue about the work that we did. Unless there's some issue about the work that we did. Yes, William. Yes, William. William?
Yes, teacher, can you hear me?
Yes, please, I can get you well.
Yes, so I have a complaint on number one.
Mm.
Number one said, what is the probability of the occurrence of a number that is odd, all less than 5 when a fair die is rolled?
William, before you
Yes,
proceed, we are going to do the revision. We are going to start on the revision. That's what we are going to do. So you check your work as you work out.
Okay, thank you.
Yes, please. Okay. Okay. Any other person with an issue somewhere? Okay, no one. Okay, so let's proceed. Let's proceed with this, and we are going to. So this is our work. This is the work that we did. This is the. Those of you who may have not seen the question, this is the work that we did. So we shall revise and move as far as the time allows, depending on the time period. As it allows, then we shall keep on moving up to the last one in that given order. Okay, but this is the work that we had. Okay, so we are going to go through one by one. So I'm going to start with number one. I said I'm going to emphasize more. I'm going to emphasize more on the dice and then the coins. That's why I'm going to put more emphasis on. So that's something that I want us to pay close attention to. Okay, let me check out my questions here. Okay, it's here. So this was our question 1. We had our question 1 as this. I hope we are all able to see the screen. Please confirm if your phone or your computer, you're able to see what is on the screen. Please confirm. Okay, yes, you can all see. Okay, so we can all see that. Now, we say that the question was, what is the probability? Question is, what's the probability? Sorry, let's see this. Okay, so the question is, what is the probability of the occurrence of a number that is odd, okay? That is odd or less than 5 when a fair die is rolled, okay? Actually, this was odd or less than 5. Now, we know that when you have your die, first of all, we find our sample space. Okay, our sample space. So our sample space is, the die is having the 6 faces. So you list down your item. So we have 1, 2, 3, 4, 5, and then 6. So this is our sample space. That's the very first thing we need to look at. So before you do anything, first look at your sample space. Okay? So when you have your sample space, then you can be able to tell what you can do. So from there, so meaning our number of the sample space is equivalent to 6 items. So whatsoever answer you must get should be out of 6, because it is now the sample space. So remember, you get marks. You always get marks when you list down this. Some of you were simply putting down your final answer. For example, if the answer is 2 out of 6, you just said the answer is 2 out of 6. Now, in mathematics, we don't do like that. We have to tell, how did we come to this 2 out of 6? We show the working. Okay? We show the working. Okay? So in everything that you do, make sure you show the working before you list down your answer. Most of you were putting down, most of you were simply just writing your answer there, and then you stop there. So in your working, the very first thing you do, list down your sample space. What do you have in your sample space? And what is the number of the sample space? Okay, that's number 1. So number 2, we now look at the events. Okay, the event E. So by the way, you can also say, let the occurrence of an odd number be A. You can call it A. So meaning, when you are looking at A, these are odd numbers. So when you look at this, can we list down our odd numbers from that set? Can someone tell us what odd numbers do we have from here? What are our odd numbers that we have here? Someone to tell us? Yes, Mariam?
Yes, we have 1, 3, and 5.
1,
3 and 5.
3 and 5. Okay, thank you, Mariam. So those are our odd numbers. That's the first thing we need to look at. Then we look at the other part of less than 5. Okay, so we can also say, let the occurrence of numbers less than 5, B. Maybe you can call it B. Okay. So we shall have B. What will be our set of events here for B? What will be our set of events B? Chemtai.
We have 1,
You have
2,
1,
3, 4.
4, 3, and what?
Yes, I'm saying 1, 2, 3, and 4.
Yeah, and also we have the 2. Okay. So we have this. Now, what we ought to do here. Okay. Now, what we ought to do here, we look at the 2 sets. Okay. And when you look at the 2 sets, we have common values that are there. Okay. We have common values that are there. Now, most people were doing this. This is what most people were doing. Actually, people took this one. I marked some people because they were taking this one, odd, and some people were taking this, actually odd and less than 5. That's what some people were taking it as. Now, when you take this one, odd and, that's why I was marking for those. I don't know if all of you were seeing this one and or all. Some people were putting this and then they look at the values odd numbers that are less than. Actually, the people were taking it as odd numbers less than 5. Actually, that is what some people was not and. There was nothing like and. Actually, that was the error that was there. Okay? It was odd numbers less than 5. Okay? This is where we were. That's why most people. This is what was being marked out. Odd numbers less than what? Less than 5. So in so doing, if you look at odd numbers less than 5, here in your set, in your sample space, you look at 1 and then 3. Okay? When you look at odd numbers less than 5, you have 1 and then 3. So your number of A will be equivalent to 2, because the set A will be having 1 and 3. This is what most people were doing. Okay, so in so doing, your probability of A, the probability of A will be equivalent to the number here, which is 2 out of the 6. And when you reduce down, you come to 1 out of the 3. This is actually what it was. Okay. The occurrence of an odd number less than what? Less than 3. Sorry, less than 5. So the odd numbers that are less than 5, we come to this. Okay. Now I think this is where William was talking about. Now, William, I hope William is there. Yes, William. William, are you there?
Yes, teacher, I'm there.
Now, you can put up your case now.
Some of us, yes, I've seen where there was an error in the question where it is supposed to be odd numbers less than 5, but then some of us we read the question as it was. They said
and how did you work it out?
So I read the question: what is the probability of the occurrence of a number that is odd, all less than 5? So I took it, you may choose either odd numbers or less than 5, because that's what the question said. So I took less than 5. So
you took
I
this
chose
one here. Oh,
no, I didn't do that.
Oh,
yeah,
you chose one.
one.
Okay, I understand. Okay, noted on that. Good. Faith and Benjamin, your hands have been up. Faith and Benjamin. I don't know whether it's Faith or Benjamin speaking. Faith and Benjamin. Not there. Priska.
For me, what I did, I got the probability of the odd, those numbers which are odd, and those ones which are less than 5. Then
And then
remember,
you
they
add.
tell us, yeah.
Then you add the two. Okay.
Then
Pardon?
that's what,
Pardon?
yeah, that's what I did.
Then you add it. But
That's
when
what
you,
I did.
but you remember when you add, you see that you get a number beyond what you have. You will get 1 point something. Priska, what did you add?
Yes,
What did you add?
I got like the probability of the odd and then the probability of the less than 5.
The odd was? How did you get?
My papers are too fat, teacher.
Okay. So what we are putting across is that when you do have that, when some people, that's the mistake some people are doing. Yeah? They were saying 3 out of 6 plus is it 4 out of 6. Here you end up with 7, which is very wrong. And we know that in probability, we don't get a number beyond 1. Okay. And a 1.2, 1.1, it does not count. Okay. So literally that is what we look at. Okay. Okay, so I'm going to close the chat in a little while because it seems people, okay. Who is talking of the GP? This is a senior 3 lesson, not a, so, okay. So that is what we literally have as far as this is concerned. Okay. So okay, let's look at this. So when we get that, that is what you're supposed to have. So this was supposed to be our answer as far as that was concerned. In that, so we list the odd numbers, and we pick out those ones that are less than what? That are less than 5, which is 1 and 3, and then we get our result there. Okay. Number 2. Let's get to number 2. Number 2 is here. Okay, we're at number 2. Okay, this is our number 2. So we say number 2 was like when 2 dice are rolled, find the probability of getting a greater number on the first die and the one on the second die. Okay, meaning on the first die you must get a number which is greater than the one on the second die. Given that the sum should be equal to 8. Now, I said step 1, we need to first come up with our sample space. So we said we have 2 dice. We looked at 2 dice the other time. So you try to come up with your table. Most of you are coming up with your tables, and you're trying to come up with. So this is one of the. Now, how you put die 1 and die 2 is up to you. So me, I can say this is 2, 3, 4, 5. 1, 2, 3. There is also 3, sorry. I also forgot 5 here. Okay. Okay, so we have 4, 5, and then 6. Then 1, 2, 3, 4, 5, and then 6. Now, what are we looking at here? Our probability is requiring us to carry on the sums. Yeah? So we try to come up with this table first. Now, this table is supposed to guide us on how to come up with that given probability. Okay. So what are we, when you roll the dice, the probability of getting a greater number on the first die. That done, actually done, the one done on the second die. So you can call this one die 1 and you call this one die 2. Okay? This is die, that's the first thing you need to do. First, check out which one is your die 1 and which one is your die 2. Okay? So when you find out that, then you can be able to count. So we combine now. It's die 1 and die 2. So die 1, this is die 1. So we have 2, 1. Die 1, die 2. Die 1 is 3, then this is 1. Die 1 is 4, die 2 is 1. Like that. So you combine them in that given form. So in so doing, you can be able to, then we move the second one, die 1, die 2. Die 1, die 2. Die 1, then die 2 like that. So 4, 2, 5, 2, 6, 2. So you keep on moving in that given order. So we have again 3, 1, 3, sorry. This is 1, 3. 2, 3. So die 1 is 2, 3, 3, 3. Then you also have 4, 3. Okay. Then you have 5, 3, 6, 3. Okay. Then we also have 1, 4. We have 2, 4. Then we have 3, 4. Then we have 4, 4. Then we have 5, 4. Then we have 6, 4. Then we move down. We also have 1, 5. Then we have 2, 5. Then we have 3, 5, 4, 5, 6, 5. Is it 6? 5, sorry, 5. 5, 5. Then we have here. Here we have, this is 6, 2. Sorry, this is 6, 2, not 6, 1. This is 6, 1. Okay. Then here we also have 6, 6. Okay. Then we continue combining. You also have 1, 6. You also have 2, 6, 3, 6, 4, 6. Then you have 4, 4, 6. Then 5, 6. And you also have 6, 6. So now that's the very first thing we need to do. Okay. So if you do not come up with this table, you will not be able to tell which one is greater than the other one. So you cannot tell. So from here is when we are going to drive our sample space. Okay. Is someone having an issue on this table here? Yes, patience.
So I think you made a mistake.
On which one?
5. Yeah.
This is 5. Good. This is 5, 1. Good.
Yeah.
Any other? Okay. We're correcting us on that. Good. Thank you. Philomena Bahita.
Teacher, on the line of 5, you wrote the last one is supposed to be 5, 5, 6. And the line 5, you wrote 6, 6.
This one? This is a 5.
Yes.
No, this is 6, 6. This one here.
Yes.
This is 5. Good. Okay. I think we are now attentive. Good. Thank you. So, any other one who has seen an issue with the table? Okay. Yes, Rain. Rain? Okay, Rain is fine. So, this is what we first carry on. Yes, Lona? Lona?
Teacher, it is not 5, 6, it is 6, 5.
This is 6. Let's rub it out. Let's erase it first. So this brings us to the point that please, when you come up with your table, you are supposed to go through and then you see it is supposed to be 6, then this is 5. Okay, you go through your table to make sure that it has been combined, the numbers have been combined well. Otherwise, if you do not combine them so well, you're going to get a wrong outcome. Okay, you end up getting a wrong outcome. Miriam? Yes, Miriam?
Sure, don't you see that this table is very long, yet there is another way to do the other simple one? This table takes a lot of time.
But you are showing the working. That is the point we are trying to say. You'll give us a second method after this. Okay, so what we are doing here is that we are trying to put across our results before we try to come up with the final thing. So from here now, we are now finding out our probability. Find the probability of getting a greater number on the first die than the second die. So let's first look at greater numbers. Let's get here. Let's get back to our tables. Let's look at, on the first die, the number should be great, okay? Then it should be greater than the one on the second one. So look here. So we have 3 is greater than 1. So this is what you have. 4 is also greater than 1. So you have 4, 1 also. So you have these ones also, 5, 1. Then we also have 6, 1. Why are we rolling out this? It's because this is our first die. We said we are starting with the first die. Then we come, these ones are equal. This one, it is not because the other one is greater. Then this is equal, so we cannot. Then here we have this. Then we also have this. Okay. Okay. So what are we circling out? We are circling out numbers where the first die, okay, whereby the very first die is having a greater number. Okay, that's what we are rolling out. I think this was 3, 3. This is it, 2, 2. Oh, this is 1, 2, 3. This is okay. Then we look at also this. We have this also. Then we also have this. Actually, even this one, someone says even this one, good. Because this is the first die, then the second die, good. Then we also have this. So you see that when you're rolling out, you see how the numbers are reducing down? See how they are reducing down? Until this is only this. So what will your first sample space for those numbers with the greater? So we say probability of a number greater, okay, die 1 greater than die 2, we shall have, you list down all these ones here, of course. This is your set. So you can list down your set. So you have where you have 2, 1, okay? Then we have 3, 1, like that. So you list them down. Remember, it is a combination. Please don't separate them. I saw some people separating them. Please do not do so. Make sure you're keen enough to know that this is a set of items. Okay, we have set of items. Okay, so we have this 42. Then we have 5, 2. Then we have 6, 2, comma. Then we also have 4, 3. And we have 5, 3. Then we have 6, 3. Then we have 5, 4. Then we have 6, 4. Then we also have 6, 5. Okay, and this is our set of items. But we are not done yet. We are not using. First of all, what is our sample space? Our sample space is we count everything. 1, 2, 3, 4, 5, 6, like that. I think everything it comes to 36. When you look through, it is 36. When you come. Now, from this set that we have created, we are going to pick out numbers whereby when you sum them up, the sum should be equal to 8. So I want someone to look through this one here. Look through these digits that we have picked out, these combinations we picked out. and you total up 2 items, and then you get the sample space. So we get numbers greater than 8. Sorry, greater than 8. Combinations that are greater than 8. Who can tell us? Combinations that are greater than 8. I've not heard boys speaking. What is happening? It's a class of girls. Eh? Where are the boys? I want some boy here. Joshua. Josh? Joshua, are you there?
5 and 3. Yes, 5 and 3.
You have 5 and what?
And 3.
Any other?
3, 5 and 3.
This is 1. Any other? Do you have any other? Hey, Josh is gone. We're still, yes, Patience. Patience. Do you have any other which is whereby when you total up you get 8? Rebecca?
So we have 6 and 2.
You also have 6 and 2. 6 plus 2 is 8.
Yeah.
Any other? Is that all?
Yeah.
That is all. Thank you. So, literally, we can now know that this is now the set that we are going to look at. But our sample space remains. Now, why am I doing all this? This is to ensure that you pick out every single detail, because these are marks. These are all marks. For if you just come and put your answer directly, maybe 5 and 3, and you stop there, they are marks for coming up with this table. They are marks for drawing out this. They are marks for this, and they are marks for coming up with the final thing. So meaning our number, the number of n greater than 8 will be equivalent to 2. These are 2 items, 1 and then 2. So meaning the probability, okay, of those numbers greater than 8 will be equivalent. The number of events, which is 2, out of the sample space. Our sample space is 36. Okay, our sample space is 36. So you reduce this down by 2 once, by 2. 2 goes into 36 how many times? 18 times. Okay, so when you please now about reducing down, reducing your values. You can reduce, you may not reduce. Okay, sometimes some papers give what you call a bonus mark. Bonus marks are always for doing this extra work that is required. So for you may get your answer, your result as this, and then they give you your 1 mark, answer 1. So because in marking we have method, we have the bonus, and then we have the answer mark. So the method 1 comes in from here. Coming up with this table is a method mark. Coming up with these extra items from here, those are bonus marks. And the final result gives us the answer mark. Okay, depending on what you would like to put across. Okay, let me talk to Patience. Yes, Patience. Patience? Okay. Is it Edify? Yes, Edify? Yes, Edify. Okay. Rebecca?
Master.
Yes.
So you mean even if I just stop there, I can earn a mark?
Stopping where? Or not? You don't
On
reduce,
2, when
out of the, yes, you do. You earn a mark.
okay.
Yes, Edify?
Where did you get the 36?
Where do we get the 36? Okay. Now the 36 is got from here. The 36 is got from here. We look at the sample space. Okay. The 36 is got as the sample space. So how do you come to your sample space? The sample space, you count all the outcomes. Okay, we are counting. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, 24. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So that becomes our sample space. Sample space are the total possible outcomes. We say in the earlier on, we say a sample space are the total possible outcomes. So these are all the possible outcomes that we have, and that's how we come to our 36. That's where our 36 comes from. Okay, let me answer some questions here. I hope Edify has got that. Irene?
I've not understood.
From where?
The circling part.
The circling part, we are looking out for the, now look at the questions. The question is telling us getting a number which is greater on the first phase, first die, a number greater than, a number that is greater than the other number on the second die. Look at this. Here we have die 1. Okay, this is our first die, and then this is our second die. Okay,
yeah,
so
yes.
when you were combining, we're saying first die is having 2, the second die is having 1.
Yes.
The first die, we are doing combinations, we are combining. Then the first die is having 3, the second die has 1, like that. So when you do, we check through all your sample space, look out for those ones where which combination has a number which is greater on the first die than the second die. Okay, that's why we are circling out these ones. Like here, 3 is on the first die, which is greater than 1, which is on the second die.
Yes.
Okay, we can't circle this one here because this is the first die has a number less than the one on the second die. So that's why we have that.
Thank you, sir. Understood.
William. Yes, William.
Yes, teacher, about this, I'm asking about reducing. Now, there are cases where the numerator and the denominator are the same. Like, for example, on this number, when you get the probability as 36 out of 36, then when you reduce, you get 1. Do you still reduce it or you leave it as 36 out of 36?
But we know that 36 out of 36 is the same as 1. Eh?
Yes.
Yes.
But then,
so being the same, you know, when you say 36 out of 36 is equal to 1, it means I can write this one here. I can write the 1, I can write the 36 out of 36. Now, this one here, it shows the working, shows you that how you got the 1, you got it from 36 out of 36. You produce 1 from there. But when someone writes it and leaves it like this, still in probability it counts. Because we know that our probability is either it's between 0 and 1. So if you write the 1, you're fine. If you write 36 out of 36, you're also fine. Okay, this person usually, I said you can reduce down in most cases. You can, it is okay to reduce. It is not also a crime not to reduce down, as long as you have written the right answer, as long as your answer is right. That is what we are looking at.
Okay, thank
you. Okay. Daphne? Finally, Daphne?
Okay, sir. No, sir, now I was asking that every method I give, I get a mark. Oh.
Yes, you get a mark. Now, when I'm having, you know, the question depends on the mark. Like, for example, if this question is having 4 marks, like normally it will have, if it has 4 marks, let's make sure we bring out all the possible methods that will give us the 4 marks. If for you from nowhere, you start listing these items here, meaning you're going to lose out marks for this timetable here. I think we are going to go to Mariam, who is going to give us her shorter method. But make sure at the end of it all, you raise up what? You know how did you come to this table here? How did you come to this set of items? It means you picked it from this side to come to this other point here. That is what, but if from nowhere you start saying the sample space is 5 and 2, then you say, meaning you're going to get your 1 mark here and you're going to get your other 1 mark here for the answer. But you're going to miss out the 2 marks for getting this general set and also picking out this other thing. Okay, so we are looking, depending on the marks that we have here, if we have 4 marks, that is it. But if, for example, we have only 2 marks here, it means we are looking at the set of items and the method that you have used to come up with that given result. That's what we are looking at. All right. I think nothing is done. Okay, let's look at another thing. Let's look at the other question as well. I think this is a bit clear. Okay, let me get another question here. So I said I'm emphasizing on the die. This is where my emphasis is, so that we try to maneuver through to ensure that we understand what goes on as far as the dies are concerned. Okay, so we are here. So we're saying 2 dice are rolled. Find the probability that the sum is equal to 1. Is it equal to 1? Yes, the sum is equal to 1. Okay, let me get this. We find the probability that the sum is equal to 1, the sum is equal to 4, and the sum is less than what? Is less than 3. Less than 13, sorry. Okay. Check out this. Okay, so let me look at this one. I think as we keep on, as we move on. So still we are following the same method. Method is first of all coming up with your what? Coming up with your table of sums. Okay, coming up with your table of sums. Okay. 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So this is, please, let's get used to coming up with this table. Why? Because it tries to bring us the results very, very, very clear. Okay, it will try to indicate that we are knowing what we, so now here we are adding up. Okay, so meaning you're supposed to get these 2 dice and then you add them up. So 1 plus 1 is 1. This is a, so we try to add this plus this is 2. This plus this is 3, 4, 5, 6, and 7, like that. So you keep adding. This plus this is 3, 4, 5, 6, 7, 8. Then here we also have 4, 5, 6, 7, 8, 9. Then 4, we are adding. 4 plus 1 is 5. 4 plus 2 is 6, like that. 8, 9, 10. Remember, we are adding by 1, 1, so we don't have to hustle much. So if we start with 6, meaning the next is 7, 8, 9, 10, 11. Then here, if it is 7, next is 8, 9, 10, 11, 12. Does anyone have a difficulty in coming up with that table? Anyone with an issue in coming up with that table? This is for sums. This is the table for sum. So meaning you're adding dice 1 plus dice 2, and you're getting the results here. But remember, your sample space now is still 36. Look at your sample space, it's still 36. Okay. How do you get the 36? You add up each of these. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that, up to the last one this side. That's how we are coming up with our sample space. Rebecca, you have an issue in coming up with that table?
Yay. No, you have explained. I have got it. Maybe.
Okay. This is Bernadette. Yes, Bernadette. You have an issue with the table?
Yeah, no, not really, but I've just joined the lesson, and it's my first lesson, so I'm having some challenges with. Okay, I'm just hoping that if you could start from the whole question, if it is okay.
Okay, now we are proceeding and we may not move back from the beginning, but maybe you can catch up and then we can be able to get at a later time. For now, please you try to follow what is there. So that is how you get it. So remember our sample space is 36 still. Okay. So in so doing, you are going to now get your number is equal to 1. Okay. Number of events for equal to 1 is what? If you look through your additions here, do you see any number equal to 1? No. We start from 2. So meaning the event is 0. So what do you do? So meaning the probability of the events of equal to 0 is equivalent to the number of events out of the number of the sample space. Our sample space is 36 and the event is 0. 0 because we don't have any number which is equivalent to 1. So it will be 0 out of 36. Please, it is important to list your events before you list them. You give us your final answer. Okay, it's very, very important. Okay, that's done. Then equal to 4, number of events equal to 4. Okay. How many? Let's look at how many events do we have that are equal to 4. Can someone tell us? Can we send a message now? Please send a message equal to 4. How many do we have that are equal to 4? Send a message. So we look out for this. So look at 4. We have 4. The sum is equal to 4. This is 1. So you look for wherever there is a 4. This is 2. Then we also have this 3. Do we have any other 4? We do not have. So meaning the events are the 4, 4, 3 times. So meaning the number is equivalent to what? To 3. That will be your number of events. Okay. Then your probability of E of the events equal to 4 will be the number of the events out of the number of the sample space, which will be given to 3 out of what? 36. So when you reduce this, we get 1. This will be 1, 2. This will be 12. And that will be that. Okay. Then the last one is those are less than 13. Look at all your totals here, and we look at which total is less than 13. Less than 13. Now, when you look at all your sample spaces, do you see that all the values are less than 13? They are between 2 and 12. And of course, even your 12 is less than what? Less than 13. So therefore, your number of events less than 13 is equivalent to what? To 36. You look at all these 2, 3, 4, all these ones are less than 13. All these ones in red. Okay, all these ones in red, all these. Okay, all these ones are less than what? Are less than 13. So meaning they are 36 in number. So therefore, your probability will be equivalent. Your probability of the event less than 13. So this is less than 13, not greater. This is less than 13 will be equivalent to 36 out of 36. So meaning you come up, when you reduce this, you come up with 1. Now, what does this mean? It means that every time you will roll the 2 dice, every time you roll those 2 dice, you will always get a number which is less than 36. That is what it means. Even this one here, this one, what it means that every time you roll, you will never get a number that is equal to 1. It is impossible to get that. So usually 0 means that it is impossible. Okay, while 1, it means that all those things are possible. Every time you roll, you will get the same thing. Every time you roll, you will get the same thing. Members, do I have any question up to this moment? Faith and Benjamin. Faith and Benjamin. Faith and Benjamin are not speaking. I don't know what's the problem. Daphne?
Sir, Master, I think I'm begging for your pardon on that part C.
On part C.
Yes.
Now we are saying. So we are saying that when you look at your sample space, all these numbers are look, cross out all the numbers. This is less than 13, less than 13, less than 13. Do you see all these numbers are less than 13? This is what we are saying. All these numbers are less than 13. So after circling them out, you count them, count one by one, and you see how many they are. Okay. Okay. I don't know if you're seeing this. All these ones here that I'm done circling are less than 13. 11 is less than 13. 12, same thing. 10, same thing. Okay. So what it means that after that you count them, and when you count them, you see that they're equivalent to the sample space. That's what it means. So in so doing, your sample space, your number of events is 36, and your number of the sample space is what? Is 36. So you're literally going to get the same thing. Okay, that's how we come to this. Okay, Geoffrey, hey, right there, Godfrey. Geoffrey. Yes, Geoffrey. Geoffrey, you're not clear. Okay. I think your network has a problem somewhere. Maybe you can check the network. Okay. Mwesigwa. Yes, Mwesigwa.
Like down there, you have done 36 out of 36, and you got it one.
Yes.
Then can I also like the?
Pardon? We lost you. Mwesigwa, we lost you. Okay. We lost Mwesigwa. Okay. Ethan. Yes, Ethan. Okay. So I don't know if some people are not. Yes, Mariam. Yes, Mariam.
Yes, teacher. That's 0. Is it okay when you get 0 and the denominator is greater than 0? I see it's not. It looks awkward. 0, at least 1.
What do you mean? I'm not getting your question.
Okay, is it okay to get a 0 when it's when it is the numerator?
Yes, any number divided by 0 is 0.
Okay.
Yes, by the principles of math. And even if you get 1 million divided by 0 divided by 1 million, you get.
Teacher, it's time for the meeting. We need to end.
All right, so members, since it is the time for the meeting, I think we may not go beyond this. Please, you share that link with your parents. I think it's in the chat. It's been shared. We may not go beyond this, but please, if you have any issue that is so we shall still share, and then I'll be going through that work again. But otherwise, you can see, I think you see the link. You can try to send it to your parents and then join the meeting. Otherwise, I know we have more numbers to work out, but we cannot go beyond this because of the upcoming meeting.
Teacher.
Yes.
Is the meeting only for parents?
Yes, it's only for parents.
The meeting is for all of us, the learners, the teachers, the parents, all of us.
All right, thank you so much. And in case of anything, still you do, in case you need any assistance, you can always contact the teacher and then you can.
The meeting is happening now. Check the link in the chat and join immediately. So I'm ending the class. Let's meet in the meeting.
Okay, thank you.